Good morning. This lesson is for my Honors Integrated 1 class. This is going to be lesson for section 20.1. So this lesson is about section 20.1. Before I get started, I just hope everyone's doing all right out there, thinking about you guys. And let's make sure that we're doing all our work that's assigned to us, so when this situation is done, we can point back and say, look how productive we were. We did everything we needed to do in this situation. And we give ourselves quite an argument to say we deserve credit for this class. Alright, so I'm just going to jump into it. It's a pretty simple lesson. I'm going to approach it by talking about what we already know and then show you how that relates to what I would like you to understand for the new lesson. So our goals today is going to be, it's an introduction to the congruent triangles criteria, meaning what we need to have happen in order to determine that our triangles are congruent. So I do remember that before we left for the quarantine, we actually had quite a few discussions of what it meant to have identical shapes. And I believe we talked about a car for a little while, where we were able to reason that if we had identical cars, that meant that every part of the car itself must also be identical, and every identical part of the car must be in the corresponding spot, right? And I told you about how I drove a car in Australia and how Australian cars could not be considered congruent to American cars, even though they had the same parts that made the cars up. They weren't in the same position, meaning they weren't next to the same part. So it was I hope I'm not going too far off on a tangent here, but with regards to this concept, it's a lot easier than cars, because cars are made up of thousands and thousands of parts. Here we're literally talking about 3 sides and 3 angles, and so it's going to be very simple to figure out if shapes are in fact congruent. Alright, or triangles are in fact congruent. So we talked about, this is what we've already talked about. We know that if triangles are congruent, if we have identical triangles, what that means to us is that the triangles have identical parts in identical positions. The parts of triangles are angles and sides, and they have to be next to the same thing. So I have an example of congruent triangles, and I'm going to highlight this. So if I have triangles ABC, or if I have triangle ABC, and I know that it's congruent to triangle RTS, what I know, and I can figure this out from this is called a congruent statement. I can figure out from my congruent statement that angle A must be the same as angle R, angle B must be the same as angle T, angle C must be the same as angle S. And I also know that side AB must be the same as side RT, and that side BC must be the same as side TS, and wrapping around, side CA must be the same as side SR. So I know who goes together based on this congruent statement, and this tells me who my identical parts are in the identical positions. Now I drew a picture to further this idea of identical parts and identical positions. So I want to just talk about here very quickly the symbols. These arcs, one arc means that it's the same as the angle in the other triangle with the one arc. So angle A is the same as angle R, and we already knew that. The 2 arcs here shows me that angle B is the same as angle T, but we already knew that. And the 3 arcs show me that angle C is the same as angle S, and we already knew that. For the sides, the 1 congruent mark tells me that side AB is the same as side RT. The side with the 2 marks, which is BC, I know that must be the same as side TS, which it is, and we already knew that. And finally, the side with the 3 marks, AC, where CA is the same as SR, the marks, the side with the 3 marks. What I want to point out is, notice that the angle with the 1 arc is between the sides with the 1 mark and the 3. And so for it to be in the same position in the other triangle, the angle with the one arc must be in that same place. So the angle with the one arc is between the sides of the 1 and the 3. So these are in identical positions, or we call it mathematically corresponding positions. Remember that, corresponding. So if we look at the angle with the 2 arcs, we see that it's between the sides with the 1 mark and the 2 marks, and that should also be true here. This angle with the 2 arcs is between the side with the 2 marks and the 1 mark. So again, they're matching up. They're next to the same identical parts, right? So identical parts are in identical positions. And so we know this, right? Section 20.1 flips the order. It's the converse. It's the backwards concept. Meaning that if we have identical parts in identical positions for shapes, we should then be able to reason that the shapes themselves must be identical. And that's what we're trying to do in this section, is we want to determine, do we have identical parts in identical positions? And they have to be all parts have to be identical and in the same position. If we have all parts being identical and they're in the same position, then we can reasonably conclude that the triangles themselves must be identical. So we're going backwards to what we've done before. Again, before we saw that we had the identical shapes, that implies that their parts must be identical and in identical positions. In this section, in section 20.1, we want to figure out, do we have identical parts in identical positions? If we have this, if that's what we have, we get the triangles are going to be congruent. So we start with this. This is what we're starting with in 20.1. And so we're going to determine, do we have this or not? If we have this, then we can move on and say, yes, I have identical triangles. If I do not have this, we cannot say that we have identical triangles. So in my mind, I'm just going over a couple things on the problems that I saw, which would be helpful for you guys. One of the things that I saw that could be helpful for these problems that you're going to be determining, do you have identical parts in identical positions? Something that you're going to need to know is that the 3 angles of a triangle add to 180 degrees. That is going to be something that you're going to have to use. Something else that I saw that will be helpful for you guys in this section is that you're going to have to find diagonal length. And remember, to find diagonal length, we use a squared plus b squared. And that's equal to c squared. And the diagonal length is actually going to be the square root of a squared plus b squared. Let me put some dots to indicate that I skipped some steps. But I think these 2 little pieces should help us to be able to answer the problems. I'm going to, I don't know off the top of my head, and I didn't write it down, what problems I'd like you to do from 20.1. But again, you know, we're starting with this. And if we have all the parts are identical and they're next to the same things, we can then conclude that the triangles themselves are congruent. So I think it's a pretty simple idea. So let's try our best to do these problems. Again, if you have any questions, please reach out to me. I'm doing my best to get back to you as soon as possible. I hope everyone's doing okay. Please email me if I can help you out.